Section 10.3, Part 1. Our objective today is to find the composite of two given functions. A composite of two given functions is defined as the function. So the composite is a function itself whose value at some x is made up of or comes from using the two functions. So f of g of x. Note that in composite functions order matters in general. So if f of g of x is one value, it is not going to be equal to g of f of x. Okay? So order matters. So, example. If I have two functions, I have, for instance, f of x equals 2x minus 7, and I have g of x equals square root x plus 3. And I want to find the composite function f of g of 16. Well, we start with the innermost function. We start on the inside, and we find the value of that function. So g of 16 equals the square root of 16 plus 3, or 4 plus 3, or 7. So g of 16 is exactly equal to 7. So now we can replace this with 7. So now we're going to do f of 7. So in the f function, I replace x with 7. So I get 14, whoops, that should just be a minus 7. 14 minus 7, or 7. So the answer is f of g of 16 equals 7. And if I was going to graph that, it would be the ordered pair 16, 7. So this is the x value that I had, and this is the final y value that I got. Okay, so this is our solution. Okay, B. So again, using the same two functions, f of x equals 2x minus 7, and g of x equals the square root of x plus 3, using those same two functions. And now I'm going to do g of f of 8. Okay, so again, I start with the innermost function, and I do that one first. I find its value. So f of 8 is 2 times 8 minus 7, or 16 minus 7, or 9. So f of 8 is exactly equal to 9. So now I can replace this f of 8 with 9. So now I'm going to do g of 9. So in the g function, it's the square root of 9 plus 3. Square root of 9 is 3. So the composite function g of f of 8 is equal to 6. And again, remember that is the ordered pair 8, 6. Okay? So it's like it starts at 8, it goes to 9, and then from 9 it goes to 6. Okay? So that's what's happening. F took 8 to 9, and then G took 9 to 6. Okay? So that's what's happening here. So now C, example 3, if I want to do f of g of x. Okay, well, the g of x function is square root of x plus 3. So I can replace the g of x function with square root of x plus 3. Okay, so that says in the f function, wherever there's an x, put square root of x plus 3 in its place. So it's going to be 2 times the square root of x plus 3 minus 7. So if I simplify that, distribute the 2, so that's 2 square root x plus 6 minus 7. So that's 2 square root x minus 1. So f of g of x is equal to 2 square root x minus 1. So this is the composite function. Notice now, going back to our first example, f of g of 16. Notice that that came out to 7. So what if I put 7 in for x here? I'm sorry, I started out with 16, g of 16. So notice that if I put 16 in for x, okay, so this is a more direct way to get our 7, okay, because this is already combined. But this is the general form of the composite function. So that was just showing you how we can do that. All right, so let's try a new one. If now my function is f of x is equal to 2x plus 1, and g of x is equal to square root x minus 1, find f of g of 4. Okay, so again, remember you start at the innermost function, and find what the value of that is. So g of 4 is the square root of 4 minus 1, or 2 minus 1, or 1. Now replace this with 1. Now go to the f function. So our final answer is f of g of 4 equals 3. Okay, so again, what is happening here is g takes 4 to 1, and then f takes 1 to 3. Okay, so so that's what's actually happening, right? So now let's do g of f of 4. Okay, and this is to show you that order matters. So notice in the previous example we did f of g of 4, and remember our f function was 2x plus 1. So we start here and we do the f function. So f of 4 is 2 times 4 plus 1, or 8 plus 1, or 9. So now we can replace this with 9. So g of 9 is going to be the square root of 9 minus 1. So 3 minus 1 is 2. So g of f of 4 equals 2. And again, notice this answer is different from this answer. And so you have to be careful of the order. You always start from the inside and then work to the outside. Right, let's do one last one. Let's do the general composite function. So let's do, whoops, need a pen here. Let's do g of f of x. Okay, so remember our f of x function was 2x plus 1, and our g of x function was square root of x minus 1. So this says, in the g function, wherever there's an x, put the f of x function. Okay? So this is the g function, so in place of this x, I'm going to put all of this. So that's going to become the square root of 2x plus 1, and then we have minus 1. So the composite function is this whole thing. Okay, so that's the general composite function.